Hello, good afternoon. Now I would like to deliver lecture on chapter 11 of product development course, titling prototyping. In this chapter, basically in the textbook, they presented the case for this kind of product in the form of iBot packboard. So iBot packboard is basically a very specific use product that was designed by a company which is related to Massachusetts Institute of Technology. I would say a spin-off company from MIT, and then later it become independent and it become a commercial company, and soon they listed the company iRobot into the Nasdaq, which is New York boss board, and they produce mainly their product for the DARPA or unit for U.S. Army. So it is basically from the DARPA research grant given to MIT spin-off company, and later they produce this product explained is 8,000 robot for the defense and home purposes. So the robot major customer is basically U.S. Army for the purpose of saving critical operation. For example, retrieve bombs, or for example, they do the operation for very dangerous task. So the robot is very capable. They can move on the flat surface, and they are also capable to go up the stair just like this. So I would say this is one example that a successful spin-off product, and later they become a commercial product in the real world. So in this chapter, we are discussing on the prototype and how it later developed into actual product. So let's see how is the real function or the real application of iRobot Packboard that was developed by iRobot Corporation. So let's have a look on this video clip.
Remote control cars have nothing on these iRobots, with features such as 180-degree tilt cameras and flippers that enable them to maneuver over the toughest terrains. These iRobots are changing today's battlefield.
Being able to support the warfighter through these robots, keeping them out of harm's way, is what makes this job so important. For each robot that comes into the shop damaged, or especially suffered battle damage, was destroyed by an IED blast, that's one warfighter that was not injured out on the battlefield.
These iRobots assist troops in a variety of different ways, from removing explosives, allowing troops to see an area from a safe distance, to recovering an injured battle buddy. As an added bonus, these robots are controlled by a device that most are familiar with, the PlayStation controller.
The robot is a unmanned battle buddy. When you can send a robot out to identify, interrogate, or defuse a bomb versus sending a bomb tech out in a bomb suit or sending a combat engineer out there. This can do everything that a bomb tech can do, just in a remote fashion.
Not only are these iRobots highly technical, tactical super machines, but they help keep our troops on the ground safe. There are several different versions of the robots, each one performing a unique task in the overall mission. As we march into the future, these robots will continue to have a critical role in the warfighting efforts. Reporting for the 1st Theater Sustainment Command from Camp Air John Kuwait, I'm Specialist Kelsey Jeffers.
Okay, there you go. That is the actual operation for iBot model packboard in the real military world. So we are discussing on the stages or the types of a few prototypes in terms of its stages of development, or in the types of its operation. So what is actually prototype? Prototype is actually a model that shows approximation of the actual product, and it can show its dimensions of interest. So it is a simplistic of actual. It is a simple approach of showing the actual product by showing its main features. And prototype is normally the process of developing the almost exactly the same of the actual intended product. So it is the approximation of the product. So normally industrial designers, engineers in design, they produce the prototypes of their main initial concept. So engineers basically develop this prototype. So that may include the hardware and the software developers that join force together in order to develop product that normally consisting of hardware and also control or interfacing with software. So these are the typical prototype that being developed out there in the industry. In the first part, I would discuss the first two types of prototype, which is in the name of physical prototype and analytical prototype. So in other words, whether the prototype shows it physical shape or physical kind of outlook of its actual final product. So it is normally made for sample. So it is like they call a look-alike product of the actual one. For example, like this is a sample actual smartphone. So this sample actual smartphone is just a physical model. It is not embedded the full features and full material, but it is merely like a sample for customer to see, feel, touch, and to have a look on the actual final shape. And for Pack Robot, this is also the actual physical sample of how the actual Packbot iRobot will look like in its physical model. The other type of prototype is called analytical. Analytical prototype means that the model must represent the product in a non-tangible manner. For example, in the form of a software draft or in the form of a mathematical simulation or visual simulation. This is for the purpose of analytic. In other words, analytical prototype is more like a simulation. It is a non-tangible shape, normally in the form of software, graphic sketch or graphic drawing in the form of like this. And it also sketches the basic shapes or the basic size dimension of the wheel or the base and so on. So this is a second type of prototype named analytical. The other two prototypes in discussion in the textbook is actually the third type of prototype named comprehensive prototype. Comprehensive prototype is a more thorough representation of the actual prototype that is being designed to be made later into actual operation. So it implements most of the characteristic, function, and also ability of the actual product. And normally, comprehensive prototype is in the full scale, which is full dimension. It is in the full shape of the actual product, and normally it is a fully operational version of the product. It is almost the actual intended product to be produced. So comprehensive also is one of the sample to the actual. So perhaps all the major function has been in operating. For example, the camera that will take pictures, and the camera can move up on this robot arm, and the radio control has been functioning well in terms of mechanism of navigation, and also all critical movement as far as moving on the flat surface or on the features of the on the tracking arm here for moving up the ladder and so on. So most major features of the actual intended product has been in operation for comprehensive model. The fourth type of prototype is called focused. Focused prototype means that it only perform or operate few attributes of actual product. Okay, so because it is focused more on few critical capability of the actual product. It could be made from like a foam or simple plastic material, or it can be the design board and the control logic board could be made by hand assembly. So perhaps like this simple pack robot is actually it is focused on testing the navigation of the robot, means going left, going forward, going backward, and also testing the movement of the robot in the actual operation. So since it is focused, so it only perform few capabilities of the actual finished product. So that is focused prototype. Here is the four-quadrant view of the prototype that we have discussed earlier. So it is the physical, and second analytical, comprehensive, and focus. Okay, so these are the quadrant. So the physical product is normally here at quadrant 1. So at physical product, normally we are testing its physical structure, physical capability, and against the focused one. So for example, and in the physical quadrant here, like we call it a Q1, quadrant 1, we are focusing on testing the physical capability of the prototype. For example, so we want to test whether the wheel is strong enough to sustain impact or load. So here, the wheel is being designed as far as its physical attributes, so that it must be strong enough to take a load, to sustain the impact of certain pressure. So we must also test is kind of the gripping ability of the wheel on the many type of surfaces, and the coating of the material for the wheel, and so on. So these are normally called physical prototype at this quadrant 1. Whereas on the second quadrant here, it is more on the analytical approach. So the second quadrant focus more on the analytical representation of the actual prototype that will be made later. So in this analytical quadrant, basically it is like a alpha prototype of system integration. So they test in terms of the capability of the system, whether will it suffer from a drop of certain height. And for beta prototype, it will be tested on the field. So it is generated to be analyzed in software or in the full scale for models. So these are basically more on analytical approach, because they want to test its ability to sustain drop. It will test in terms of rough surface if it is moved on the actual field. So these are more towards analytical level. The third quadrant here, which is called focused and comprehensive. Okay, so this is more on the aspect of focused on the, for example, the color rendering, right? So on it is focused on the attributes, the key attributes of the prototype. The prototype, whether it can sustain, for example, heat, right? Heat dissipation, and it is normally being tested in the lab, or in the mathematical mode, or in the simulation. So this is what they call more on focused prototype. So where else in the quadrant number 4, which is here on the bottom right, we call it quadrant Q4. So this is pretty much what we say the comprehensive model, in which most major function of the actual product that will be made must be performing or must be successfully executed. So including the user interface hardware linked to the dynamic simulation, right? And it is a full dynamic representation of the actual product. So I would say the comprehensive model is the full scale of actual product, which is at the quadrant somewhere here. If you take a look at this far end of the bottom right, in this quadrant, which is at quadrant 4, at the most maximum area, which is almost fully comprehensive or almost fully analytical, actually this is not achievable in terms of actual prototype. So this is the maximum capability in terms of it being a comprehensive prototype. It is almost at the maximum of the analytical model. So here, this quadrant is, I would say, the most ideal product, in which normally not that feasible due to costing, due to material, and due limitation of time. So I would say